Spring break, Mr. Gaffney?
I mean, it was better than coming into work, but I've had much better, probably like most of y'all.
Yeah,
Expectations of what you can and can't do.
true.
It wasn't as exciting and eventful as years past.
Mm-hmm.
All right, I think we'll go ahead and get started. And I got lots of announcements, some skipping tours. Let me just kind of go over. Some of it doesn't apply to you since you guys are already on the classroom, but I will word out to the 3 or 4 that we're missing right now. There's been some issues and phone calls and reviewing of classes, of some improper things being on Zoom and recorded and then going on to YouTube. So to minimize the likelihood of that occurring, some of this is old news, but you got to have an identifiable username, okay? You got to have your camera on. And after today, if you're not in it, start a class within the first minute or 2 of class, then we're not supposed to let you in. So just make sure, we only have you for 50 minutes, best case scenario. So just make sure you're in at the start of class. Otherwise, the only other option is to watch it on YouTube, which is even less exciting than doing it live in person. At least we can do a little bit of interaction and Q&A stuff, but on YouTube, you just got to sit there and grind it out. So just make sure you're in at the start of class. No vaping, hats, food, hoodies. Your bed is your desk, okay? Because there's other folks besides you guys watching these, so they want to maintain a standard of decorum that is good for everybody.
Sure. So you can't wear like a Bed 18 hoodie?
Just you can wear it, but just don't have the hoodie,
Okay.
parts of your face. Again, just, there's been some issues. I even got a call late last Thursday night on an issue on reviewing a class. So we just kind of minimized, any kind of not so great things happening. All right, so some of this may be old news from your earlier classes, but I'll just kind of update you. What you heard and haven't heard. Our last day of class for in here is going to be May 20th, okay, which is a month from today. I think that gives us, after today, 9 more classes together. So I may cherry pick a few sections and not go in sequential order like we've been doing all year, just to get you prepped, particularly you guys that are going to go on to next year or one of the calculus classes. There's not going to be any semester exam, okay, which is good for you guys, good for me, I guess, because it'd be hard to administer and hard to grade, so there's no semester exam. So what's going to occur is the 3rd quarter and the 4th quarter are each going to be worth 50% of your semester grade. 3rd quarter and 4th quarter, because it's usually 40-40-20, now it's just 50-50. Does that make sense? Any questions on that? Just make sure I turn the record button on. Yeah. Okay. Everybody got that? Any questions? All right. Now, Blackbot is current and up to date. Okay. Well, unless you've given me something in the last 3 or 4 days, I spent like a couple hours each morning doing each class, trying to get it up to date. Now, some of you, I think there's 3 in this class, I don't have the 5-1 quiz from before Easter break. Now, what could have happened is I've got 6 quizzes between the 2 classes sitting over on my desk that don't have a name on them. So one of those 6 could be you. So between now, actually sometime today, get on Blackbot and see if you're missing that 5-1 quiz, if there's a 0 or no grade in there. And if it is, you may be one of the guys that didn't put your name on the quiz. Just email, don't put it in Dropbox. Anything that you're giving me that's extremely late, because I've got 5 classes and probably 1 or 2 Dropboxes per week. I'm not going to go back 3 weeks ago or 4 weeks ago and look at Dropbox and figure out who I've graded and who I haven't. So anything that you're giving to me that's extremely late, just email it to me, because it'll get lost in Dropbox, a Dropbox from 3 or 4 weeks ago, just because I'd almost need a full-time secretary to manage that. So if you're going to give me something late, and if you're one of the three, and I can tell you who I don't have quizzes for, Cornett, Melendez, and Myers. And again, you could have submitted it, but with no name on it. And so I've got it sitting here, but a couple of you guys that have unique handwritings I can recognize, but if your handwriting's not unique, then I can't.
Here's the 5-1.
5-1 quiz. So it might be sitting right there on your desk or in your notebook. Just resubmit it to me, but do it via email.
Yeah.
I don't have to go back fishing through Blackbud. No penalty, just I'll compare, reverse, don't change anything because I've got the original, just didn't have your name. Let's see. And then also you may have noticed a bump in your grade in the last several days. I turned the switch on to drop one quiz, one rep, and one classwork homework grade. So you may have seen a little spike. It definitely didn't hurt anybody, but it could help you. And that's what maybe caused the spike, or I found some stuff that you submitted that I didn't have. You may want to look at some of the other stuff that you may have zeros for. Before, I'm not going to go crazy getting stuff that you didn't turn in 3 and 4 weeks ago that I'm not going to take late work post Easter. All right, so that's kind of one quiz because the quizzes do have more weight than a classwork grade. All right, so that's kind of the housekeeping chores and IOUs and notes and stuff. Anything I can clear up before we jump into today's lesson? Any questions? Everybody good? Let me try something here. Let's do something here. All right. Do one last housekeeping thing. Just Mr. Ratliff, Mr. Melinda, just make sure you got your camera on. Let's see. Okay, any questions before we get started? All right, does everybody have section 5.2 problem set 3A that we were working on? We were working on, just backtrack, see what I'm doing. So we were working on the Wednesday before Easter break. It's the one that the synthetic, the formula recipe for synthetic division.
What you say it was? It was probably say 5.
5-2, number 3A.
Number 3A.
Yeah, it's got the formula, the recipe formula for
So I can get it real
new
quick.
synthetic. All right, and just as a refresher, we're dividing polynomials, and you've got two options, except in the circumstance we're going to talk about before the end of class, that you can use either long division, which a lot of people used to be real good at because we did a lot of that back before the advent of putting calculators in everybody's hands. But now with the advent of calculators, long division kind of went by the wayside. Let me grab a pencil real quick.
Hi, guys.
So we're not as good in long division as we used to be, all right? Mr. Bigelow, just you missed the morning announcements, but you've got to be in on class at the beginning of class prior to within the first minute or two of class time. Otherwise, we're no longer permitted to let you in. So your only other option is to watch it on YouTube, which I think I failed to mention. If you're going to watch it on YouTube, you've got to get all or part of the 45 points credit as part of your 45 for each class and 10 for office hours for your weekly rep grade. You got to watch it on YouTube and then write a 5 or 6 sentence paragraphs kind of summarizing whatever was covered in class to validate or confirm that you did watch it. Okay.
Yes, sir.
Let's see, Mr. Bigelow. Okay, so we good to start on, go back to 5.2 and dividing polynomials? Good? All right, so if you look, what I did is those of you that submitted this problem set in Blackboard, which you were supposed to do prior to class today, and there was a minimal number of you that did that. I've posted the answers on the board because it's real hard, you know, for me to look at them and then grade and correct them and then get them back to you. So hopefully if you've got that sitting in front of you, I didn't put number 1 on here, but here are the answers for just pretty much as it's laid out on your sheet, front and back, 2 through 9 and 4 through 10, okay? And don't worry about copying the answers down, but I put, just as to refresh our memories, let's see, which number did I do here? It was number 8. Yeah. Yeah. This is actually number, make sure you can see that. Let me get it over there. This is actually number 8, where we're dividing 4x cubed minus 25x squared plus 4x plus 20. And I'm just showing you the synthetic method here as a refresher, because it seems like in years past, most of you guys preferred synthetic over the old long division. All right, and just as a refresher, we just take the coefficients down as written. The 4x cubed, we bring down the 4, the negative 25x squared, we bring down the negative 25. Plus 4x comes down as 4, and the plus 20 just comes down as 20, and we're dividing it by x minus 6. So we take the second half of the divisor, which is negative 6, we reverse the sign, and just put it right there. And then you draw a line with leaving a row in between where you draw the line. The 4 came down as written. We go 6 times 4 is 24, all right? And now we add, whereas in long division, we subtracted. And the reason we add as opposed to subtract is that we reverse the sign of the negative 6. So most people are better and more proficient at adding than they are at subtracting. So we go 6 times 4 is 24. We add the negative 25, and 24 is a negative 1. Then we take that 6 and multiply it times negative 1 is a negative 6. The negative 6 and 4 added together is a negative 2. And then the 6 times a negative 2 is a negative 12. 20 plus a negative 12 is a positive 8. Well, when we just did all this, the only thing we divided by was the 6. We didn't address this x here, all right? So to address that x, we just, if I divide each one of these by x, it just reduce, remember when we divide like bases, we subtract the exponent. So x to the third over x is x squared. So you just reduce the exponent by 1. So the 4 becomes 4x squared. The negative 1 becomes negative x. The negative 2 has no, because we've got x over x equals 1, so it goes away. And then we've got 8 as a remainder. It's 8 divided by x minus 6. Now, there was a couple of you, Mr. Walker, I think you were one of them, just looking at your work. There's a couple of you that were putting the whole answer over x minus 6. The only thing you put over the divisor of x minus 6 is any remainder after that last constant that doesn't have a variable, an exponent on it. So this is the only part that is over x minus 6. Remember, you know, if you divide it by, I'm just going to make something, 8 divided by 4, 37. And let's just say it was, I don't know, 51 remainder of 4, and I'm just, or let's say 3. So there was 3 left over that didn't go into 8 equally, so it'd be 51 and 3/8. Some of you were taught 51 R 3/8, remainder of 3/8. It's the same principle, same practice, same concept.
Mm-hmm.
That makes sense? So don't put anything over x minus 6. It's some of them don't have remainders, right? If you get down to the constant, here we had like kind of 2 constants as we were putting the variables and exponents back on it. If it didn't have this, there'd be no remainder. Some of these don't have remainders. I'm going to come back over to here. So take a look. Hopefully you've got your worksheet there in front of you. Back up so you can see. I'll do 3 3579 on the back. Just take a look, and then I'll slide over to the evens on the right. Take a look at these and see if that they match up with your work, and I'll be glad to either walk back through them or clarify, or if you want to see a long division methodology of solving one of these, I'll be glad to do that. So check your answers versus these. Hopefully they're all right. I kind of double checked them, but I too can make a mistake. I'll slide over to the even numbers here in just a second, just to give you time. Are we getting these answers? Are we getting them right? I think you may see a couple of these on the SATs. You know, you don't need to be an expert or pro, but you do want to be capable of solving these, either using the synthetic method, which most prefer. And I think it's I kind of like it better. It's a little more simplified. You just got to make sure you put the variables in the proper exponents back on the coefficients, as the final process. It seems like just from teaching this in the past, a lot of people just aren't real big on the long division.
What's the one at the bottom?
Can you not see it? Let me come.
All right, I see it now. Thank you.
It's 6x squared minus 2x plus 3 with a remainder of plus 6 over x plus 5. Sorry about that.
You're good. Thank you.
Is it okay if I slide over to the evens?
Yeah, you're good.
Let's see here we go. Let me back up. See if I can get them all in. All right. Like I said, I just worked. This work here that we kind of walked through there is just number 8. And if you want me to walk back through any more of these, let me know. We're gonna do a few more of these on a new problem set after we can kind of go over the review of this. So it's not your last chance. Any questions or anything I can clear up? Does it make sense? And are we getting these answers? You guys know the drill. Like anything else, the only way you're going to get, fairly decent in doing these is you got to sit there and do something. As you probably know, if you can set aside 20 or 30 minutes and do, 5, 6, 7 of these consecutively, you should be pretty decent at doing these. Anything I can clear up? Anything on this problem set before we move on?
Can you go back to 7?
Dang, Cat.
Can you see it? I just got the little version of you guys. There we go. Yeah. Okay, we good? Okay, so I don't know, half hour ago to an hour ago, I in Blackbaud put a new Dropbox and attached this next problem set, and it's kind of just more of the same. And it's the last problem set we're going to do on this section because. If you do these, I think that'll give us close to probably 35 or 40 problems on this, various dividing of polynomials, and you'll be pretty good on it. So this is the last problem set. It's 5-2, 3B. It's in there now. I don't know if you're capable of printing it out. If you are, then you're a little bit ahead of the game. But if you're not, that's fine also. I'm going to walk through a couple problems, and I've got them numbered in conjunction with the problem set itself. So make sure you write the numbers down so that we don't have to duplicate efforts, and you'll have that many more done. And then on Wednesday, you're just going to tie up any loose ends, and that's going to wrap up this section, and then we're going to move on. And then I'll put a quiz for you to do and submit by Friday night on this. Okay, and we're going to start another section during the second half of class on Wednesday, just because I'm trying to get as much decent stuff covered to get you prepped, particularly you guys who are going to take pre-cal next year. So that's the plan. The quiz, you just, of course, do it home on your own time and just have it back into the Dropbox by Friday at like 8 p.m. or something.
Sorry, I get my phone charger real quick.
I'll go over that and more the specifics on it on Wednesday. Say it again.
I get my charger real quick. My phone about to die.
Yeah. Okay. So, any questions before we just kind of go over some do's, don'ts, watch out for and make sure of last problem set? All right. If not, let's see here. Yeah, I'll make sure I get this in so you can see. Grab it. Do this. All right. So, if you want to, this is the actual problem. Sorry for the different inks. I'm just making sure you can see. So this is going to be problem set 5-2 3B. And the first problem is this one here. All right. And if you look at it, you kind of want to do those ones that how we started this section, where if, like you had like 34f squared plus 16f plus 8 over 2f. All right. And you want to divide 2f into each one of these. But this, you can't do that with this being a monomial and this being a polynomial. So we have two options here. What is it? How can we divide this? Because this doesn't work with this style problem, because you're dividing a polynomial by a polynomial. So we got to use either one of two methods. And they are, anybody?
As well, long division.
Either going to do long division or we got to do synthetic. Okay. I'm going to do long division on this one, just since we haven't done it for a while, so that if you like it and you want to add that to your knowledge base, we can do that. And then I'll do the other one that's similar to it with synthetic, since I already kind of demonstrated synthetic. So really what this is, I'm just going to rewrite it. Let's see here. I think that, let me make sure I wrote that right. Yeah, that's correct. Okay. So remember, we want to get these to zero out going down the line, working from left to right. So remember that. Secondly, when I want to zero them out, I put the exact same variable with our base with the exact same coefficient above each other. So if I was divided by f, if f squared was my multiplier, I'd put f squared here. If it's an f, it's going to go, if it's 2f or 200f, it's going to go here. All right. So to get this to cancel out, what I'm really looking at is I'm focusing on this and this as my first attempt. So really what I'm looking at is how can I get that f squared to zero out? So I'm dividing f squared by f, which, if you remember, is just 2 minus 1, which equals f, right? Because when we divide like bases with exponents, we subtract the exponents. So if there's 1f and f squared, I just put that right there. And then, but I've got a a polynomial here, so I got to multiply it by both of these. So f times f is f squared, which is what I want. And f times 2 is 2f, right? So, and then remember with long division, as opposed to synthetic, we're actually subtracting the lower part of the problem from the upper. So f squared minus f squared zeroes out, which is perfect. There's nothing left there, all right? Now I've got 7f minus 2f, which leaves 5f, right? You might want to put the negative here to remind you I got to subtract. All right. So the next thing is I want to cancel out, I want this to zero out 5f, right? So really what I'm looking at, whereas we did this for that first part of the problem, the next part of the problem, let's come here, is what's 5f over f equal? You see that all right? Well, f over f cancels out, so that equals 5 times, right? So f over f equals 1, so my answer is 5, so I'm going to put a plus 5 here, right? So 5 times f is 5f, and the 10 comes down just as written, positive 10, don't have to put positive, well, we will for argument purposes, all right? And then 5 times 2 is 10, all right? And then we just subtract the lower from the upper, all right? 5f minus f, 5f zeroes out, and 10 minus 10 zeroes out. So my final answer is f plus 5. Does that make sense? Any confusion I can clear up? Everybody's good? Everybody's quiet? All right. Okay, so that's number 1. So if you want, go ahead and label them as I'm going to skip numbers here in a minute. So just write them down, that way you don't have to repeat doing those if or when you print out the sheet or copy the problems off the problem set. So here's the next problem. It's 2x squared plus 3x minus 14 over, I forgot to write that down, x minus 2. So this numerator is being divided by this denominator, all right? Okay, or we can do, I'm going to do this just for argument purposes, same thing, right?
Can you do this problem in the other way?
Yeah, I'm going to do it synthetic, okay? And Mr. Ratliff, on yours, I noticed you didn't kind of finish this. You did the synthetic, but then you didn't put the on either the first one or the second one you sent me. We didn't put the variables back on there in the exponents. Okay, so it's just kind of the last thing you do. Okay, so we're going to do synthetic this time. So the 2 just comes down at. We don't even need to do that. We're just going to bring the 2 down as written. We don't care about the base and the exponent at the moment. Then we got a 3 and we got a negative 14. Make sure you keep the signs as it's written. Don't change the signs because then you're changing the problem. And we're dividing by x minus 2. Now remember synthetic, we're actually going to use this constant here, but remember we changed the sign on that. So it's a positive 2. I just put it kind of like a little box here by itself and kind of isolate it so you don't get it mixed up, the divisor getting mixed up with the initial part of the problem. And then we draw a line below the 3 numbers or however many you got with a space to write numbers. And the 2 just comes down just as it is, right? And now that's kind of the setup. So now we're good to go. 2 times 2 is 4, okay? Right, and now remember, because we changed the sign here, and I didn't just arbitrarily like doing this, because of changing the sign, contrary to long division, we actually add the 2 things. So now we got 3 plus 4 is 7, right? Everybody good so far? Now we're going to multiply 2 times 7 is 14, and we got a negative 14 and a positive 14, which zeroes out. Okay, so we've divided this here by 2, but we have not addressed the division by x, all right? 2 ways you can look at it. I just look at it as, okay, if I'm dividing by 1 less than this, x squared over x equals x, kind of like similar to the above. So that's one way to look at it. Or just since we're divided by x, just start with one exponent less than what the original problem had. So this becomes 2x. We'll put the positive on there. That would have been our remainder, which isn't anything. So there's our final answer. It's the 2x plus 7. Questions or confusion, or some of both? Anything I can clear up? Ready? I'm going to throw you a curveball in the next one. You ready?
Sure.
All right, curveball it is. Since we're not getting any baseball, unfortunately. Okay. All right, this is where you got to watch out. We want to do long or synthetic? If I have time, I'll do both. What, synthetic? Okay. So we've got a cubed. Let's see, can we see all right? A cubed minus 64 divided by a minus 4. All right. On all of these, which I haven't brought up because it hasn't been an issue, but you've got to account for every exponent from the whatever you start with all the way down to the constant. So here there's no a squared, there's no a or a to the first power. So we've got to put placeholders. We talked about this, I think, before Easter break, to make this problem work, whether you're doing synthetic or you're doing long. So I'm going to slide over just a bit and do this to the side. So I've got a cubed. I don't have it a squared. I don't have it to the first power, but I've got a negative 64. And I just use zeros because I don't want to throw another variable in there. Although if you want to use something else for a placeholder, you can. But I've got to have a placeholder for a unit squared and a unit to the first power, and then we've got the constant. Like I said, I hate to throw another variable in there. I don't want to put an a because it's going to change the problem. I hate to use x. You could use an x, but then it's like another variable. It could get messed up as part of the problem. So I just use zeros just to hold the spot, all right? And we're divided by a minus 4. So the 4 goes, well, let's do the we're going to pull the coefficients off these variables. So I got 1, I got 0, I got 0, and I got negative 64, all right? And we're divided by a minus 4. So we're going to use 4. We're going to change the sign. Are we still on the screen? Yeah, sure. If I get out of your screen or off your screen, let me know. All right, so there's the setup. We draw a line below, so I've got room to write above and below that line. The 1 comes down as written, okay? And now we start the process. 4 times 1 is 4, okay? Now remember, we're adding, not subtracting like with long division. Now we got 4 times 4 is 16, all right? Oops, I'm sorry, I'm getting ahead of the game. I'm thinking ahead. All right, so then we add 0 plus 4 is 4, all right? And then we go 4 times 4 is 16. There we go. Sorry about that. A couple steps ahead. All right, and we got 0 plus 16 is 16. And then we got 4 times 16 is 64. 64, a negative 64 and a positive 64 zeros out. Okay, so we addressed the dividing by the negative 4, but we haven't addressed dividing by the a. All right, so a cubed over a is equal to a squared. So this becomes a squared minus, plus 4a plus 16. That was our remainder, and that's our final answer. Let me just double check, make sure I didn't lead you astray. Yeah. You see that all right? Let's see. I got a lot of glare on my screen. The key thing is you've got to recognize that I'm skipping a couple exponential powers, so I've got to put a placeholder in to resolve that. Okay. And you got to do that whether you're doing long or synthetic. Do you want to see the long version of that same problem, or are you good with just a synthetic?
Yeah, I'm pretty good.
Anybody want to see long? It'd be this, setup would be very similar. So it'd be a minus 4 over a cubed 0 squared 0 minus 64. So the setup would be, this would be fairly similar, all right? So the first thing I'm going to address is I want a cubed to zero out. So I'd have to multiply a times a squared for that to work. So I go a squared, that's a squared minus 4a, right? I'm just going to go ahead and finish it just to show you both ways work. All right. I'm sorry, that's a cubed, that's 4 minus 4a squared. Now remember with, you see all right, with the long division we subtract, so that zeroes out, and this becomes 0 minus a negative 4a squared is a positive 4a squared, right? And the 0 comes down, all right? So to get rid of the 4a, for the 4a squared to zero out, I'd have to multiply this by 4a, right? So we do 4a times a is 4a squared, and 4a times negative 4 is a negative 16a, right? Subtract again, that zeroes out, and this becomes a positive 16a. And I may be getting off my screen here. Let me come down a little bit more. All right, and then this negative 64 comes all the way down. And you can see what's going to happen. All right, so I'm going to have to multiply this guy for the 16a to cancel. I'm going to multiply a times 16. 16a is 16 times a is 16a, and 16 times negative 4 is a negative 64. Right? Subtract these two things. That zeroes out. That zeroes out, and there's the exact same answer. Both work. I think this is a little cleaner, neater, less likely to make a careless error, the synthetic, but you choose. And I would just go with one and stick with it. Questions? Confusion? Anything I can clear up? All right, that's curveball number 1. Curveball number 2, and you may see this as a bonus. All right, look at this problem. Does that show up okay? Number 10. I got 4x squared minus 2x plus 6 divided by 2x minus 3. What's the curveball in this thing right here? What's the issue that's different that we haven't been exposed to? So I'll take a stab at it.
No x squared.
Go ahead.
Out this guy right
You're
here.
good.
The variable in the divisor has a coefficient other than 1. So, listen closely. The only way I can solve this is with long division. Synthetic does not work when the divisor with the part of it that has, with the variable has a coefficient other than 1. So I've got to do long division. And the problem set, if you know, when you print it out or look at it, and I put a box there just to throw the flag up for you so you know. Problems 10, 11, 12, and 14 can only be solved by long division. So I'm going to walk you through number 10 so that you know how to do 11, 12, and 14. Any questions before we do that? And then that's going to kind of wrap up what I want to go over with you today. Does that make sense? I can't use synthetic because this has a coefficient other than 1. Everything we've done so far with synthetic, and actually I think also with long, it's always been like x minus 7, t plus 4. There's been no coefficient on this. So the setup Let's see if I get a little better. Let's see, make sure I get you. So it's going to be 2x minus 3, and then 4x squared minus 2x plus 6. So there's the setup. All right. So what the process is still the same. It's how many 2x's are in 4x squared? Or another way of writing, the way of writing that is this, right? So what's that equal? It equals 2x, right? 4 goes into 2, or 2 goes into 4 2 times, and x squared over x equals x. So 4x squared divided by 2x is 2x. So again, remember, we always write the same base with the same coefficient on top of each other. It always is in a line, in a vertical line. And so far? All right. So now we just multiply 2x times the divisor. 2x times 2x is 4x squared, is why we used 2x. 2x minus 3 is a negative 6x. Okay? And then remember, long division, we subtract. So that zeroes out, and I got negative 2x minus a negative 6x, so that's the same as plus 6x, and that equals 4x. And then the 6 comes down. All right? So now I want to know how many 2x's are in 4x. It's 2, right? That equals 1. 2 divided by 4, or 4 divided by 2 is 2. So it's a plus 2. So 2 times 2x is 4x. And 2 times a negative 3 is a negative 6. All right, let's see here. All right. Okay. So 4x minus 4x is 0, right? And 6 minus a negative 6 is a positive 12, right? Because it's the same as 6 plus 6. So it's 2x plus 2 with the remainder of 12 over 2x minus 3. Am I still on the screen, or did I slip off? Does that make sense? The watch out for, the two watch out for and be careful of is if I'm dividing by a polynomial, the divisor with the variable has a coefficient other than 1, you've got to use long division. That's watch out number 1. And then watch out number 2 up here is if we skip sequential exponents. You've got to put a placeholder. That's the two things that can trip you up. If you can kind of mentally incorporate that into your methodologies and your thought processes, that's the 2 things that can mess you up in all this. All right. So we did 1, 2, 3, and 10. Let's see, there's how many are on there? There's 14 problems, so we did four of the 14, so you got 10 to do between now. If you could put them in the Dropbox by tomorrow evening, that way I can take a look at it and see how you're doing, make sure we can catch any mistakes or errors and get them worked out. We can talk about it in class on Wednesday. So let me go over any questions on the lesson. Let me just make sure, Mr. Landis, Mr. Bridges, Mr. Myers, you're not online, are you, by chance?
I know that Tommy couldn't get in because like the link wasn't working.
Okay. And then Mr. Cornett, Melendez, and Myers, just look for that 5-1 quiz. You probably have it, and resend it to me in an email.
Okay.
Because you're probably one of the ones I have sitting over here with no name.
Okay.
I don't want to arbitrarily guess. You know, when you're in class, I can say, "Hey, is this yours?" And you say yes, but I don't want to arbitrarily assign wrong quizzes to the wrong person. All right. Well, I think we've got about 2 minutes left. So do the other 9 or 10 problems on this 523B. Drop them in the Dropbox by tomorrow evening. I'll take a look at it before class on Wednesday. We'll wrap this class up, this section up on Wednesday. And then I'm kind of debating which section we're going to jump to next, because probably only going to get through sections, maybe 4, but 3, at least 3 before the end of the year. And I want to pick the sections that are most valuable to you, particularly for you guys that are moving on to pre-cal next year. Any questions on anything we did today? Are we good?
Yes, sir.
Yes, sir.
Okay, still doing office hours in the afternoons, 2 to 2:30. If you think of something after this class, and it also picks you up an extra 10 points, more points towards your rep grades if you want to do that. And Fridays were 9 a.m. to 10 a.m. So you got your last shot at doing that on Friday. If you don't do it during the week, but it's a good chance if you got questions that you want to talk about in a non-classroom environment.
Mr. Gaffney.
You need to.
Mr.
Alright.
Cash, Mr. Cash's computer died. He just wanted me to let you know.
All right. Everybody good?
Yes, sir.
Yep.
Okay, hang in there, and
All right.
I'll see you before. I'll see you in 4 to 8 hours.
Yes, sir.
All right.
Okay.
Bye, Mr. Gaffney.
Have a good couple days. 2 days. All right. Take care. Mr. Abelhausen.